Hello everybody, my name is Barsh and we are talking about Jetson Orin Nano module with system on chip on it. And also whole module is on carrier board, which is usual setup of J3011 array computer. Specifically, we in this chapter we will talk about gigabit Ethernet port, or not just port, but whole Ethernet or GBA or gigabit Ethernet connection, and how does it looks like on this mini computer. What can we say? It's yes, it's visible here, and by default there is one. It's marked 5, and by default there is only one of that kind of Ethernet port, and it's GBA, so it means it going up to 1 gigabit per second. Uh, with fast speed. So that's all clear. Also, possible speeds are 10, 100, and 1000 megabits, or in total 1 gigabit per second speed. Further, we can say or check out the symbolically represented how does it looks like. We have carrier board. On carrier board we have Jetson Orin Nano module or system on module, and on that module we have beside other components we have system on chip or in system on chip, which have a MAC address, and that's level 2 or MAC layer on it, which is interconnected with PHY layer, which is also on module, uh, and that's specifically starting with the Orin. In comparison with the older models, the interconnection, the PHY layer or layer 1 is on module, and the interconnection is not like older versions. It's going through PCIe, which implies that it can be a lot faster than usual ones, MII or something like that. And then interconnection with the carrier board of module is, in sense of Ethernet, is MDI or medium dependent interface, and then go through magnetics and then port RJ45. So we see clearly what is where on this, and we see layer 2 here inside of chip, dealing with packages according to the MAC address, and layer 1 or physical layer is also on the module. So that's the basically representation of what's going on here, but we can see from the documentation that if we have module and we have gigabit Ethernet, especially this means PHY layer, a chip is here, so interconnection, as it was said previously, and that thing it was takeover from the documentation. Interconnection from Orin to PHY layer is PCIe, and then going through the MDI and connection of SODIMM pins, which there is 260 of them, and the specific pins are meant to be used by Ethernet communication, and that's GBA, MDI. So I think there is a 8 standard pins, and I think signal pins for the LED for green and yellow. But we will see that in later. So boundary between module and carrier board is here, and we will see these interconnection with carrier board. Also another representation from another document saying that we go from system on chip, which have a MAC 2, a MAC or layer 2 or MAC address, and then go through PCIe, then to PHY layer, and then from this filer through MDA and magnetics, which is not shown here, to the RJ45 port. So layer 2 and layer 1 are on the module, so uh, it's obvious from this documentation representations. Also, there is a pins that are interconnection from the module to the carrier board are given here. Number 194, 188. These are for the signals for the LEDs, yellow and green, and then goes these pairs 184, 86, 90, 92, 96, 98. So there is 4 of them for the transfer of data. And the pin type, it says MDA. Also, what can we say here? Yes, this is interior of the system on chip, and representation it says U Phi 2. There is some markings of probably built-in some kind of variables where we storage those things which are representing actually data to be transferred to the filer which is on the module, which is represented here, and then MDI 0 pair, first pair, second pair, and third pair are given here, and also these LEDs. And there is representation of pins which are going from the module to the magnetics, and then RJ45 connector, and these are probably for the programming assigned names of some variables where we storage important things, as you can see here. And we can discuss this more later if we find some documentation and know what is what here. You see here TX, RX. Probably this means that there is more of them. But we will see later also clock lines to the phi layer. So this port is meant to. There's also other phi ports from the system on chip, but this one is probably specifically for the Ethernet communication via PCIe. But in any case, this should be PCIe PCI Express lines for this phi layer or phi chip. Okay, good. Then we can go further. Yes, now we are on carrier board. These pins go out from the module to the carrier board, and then go to the magnetics circuit, and after that on RJ45. RJ45 here also signals are coming this way. One is their connection, and another one is connection activated. As you can see, link should be is connected, and active is probably for the when so that always on RJ45 port, or not just always, but usually on switches you can see a yellow and green signal LEDs. One is for the data transfer the signal, and the other one is it active or not. So there's other things which can be discussed later, but also interesting thing, there is power of the Ethernet possibility which coming this way. Uh, and yes, this is that we can power device, some kind of device over RJ45, or to power this device through the RJ45, I think also another way around. But I'm not sure about that. I must see it and go through the documentation. But just to remember that there's PoE option also given here. And yes, this is also again specific pins for specific, let's say, data links, which is visible here. We saw this before. Um, uh, yes, J15 was on this previous picture, but yeah, that's just another representation, or given the pin so on a SODIMM spectra of out of 260, which pins are for the Ethernet communication, and for these four lines, 0, 1, 2, and 3, probably one is missing here, or negative for let's say these three. The important thing and some kind of recapitulation is that we know that we have on a system on chip, or in system on chip we have layer 2 or Mac interface, and then we have PCIe, we are going to layer 1 or Pi, and then through the MDI we going on carrier board, magnetics, and RJ45. Just to be clear, do we need or not need a filer? It's a built up or built in. So if we only want to use module, we are sure that we already have phi layer, unlike the previous models which phi layer was interpreted or given on carrier board, but for the Orin it's given here. And let's say there's always, let's say, we can make surroundings and have only the chip, and then make surroundings. Then we only have Mac layer, and then if we have a module to use, then we know that we have also filer, and then we need to provide carrier board, and so on and so on, and what we need to provide on carrier board for the interconnection with other devices via Ethernet. So boundary is given here, and given here, and what we need for the specific things in case of Jetson Orin Nano model, or just Orin chip. So it's good to have this information in head, independence of what we are projecting and what task we are actually taking over, and what are we dealing with. So I think this is enough for this time, and we will discuss these things more, or probably later. So until next time, bye.